Welcome to today's podcast, and today we are discussing an interesting topic that is plant protein versus whey after 40. Does the source really matter? Let's begin. Imagine standing in front of two containers of protein powder. One is whey protein, the supplement that has been described for decades as the gold standard for building muscle. The other is a plant-based blend, perhaps made from pea and rice protein. It costs about the same, maybe easier on your stomach, and might better align with your dietary or environmental preferences. But once you are over 40, the decision can feel more important. You may have started noticing that maintaining muscle is not quite as easy as it was 10 or 20 years ago. You want to protect your strength, support your training, and avoid choosing a protein that could hold back your progress. So which is better after 40, whey or plant protein? The evidence suggests that this may be the wrong question. The more useful question is, does the amount of protein you consume provide enough essential amino acids, especially leucine, to stimulate muscle protein synthesis? Today, we will examine why whey often performs better at smaller doses, why properly formulated plant protein can produce similar results, and how to choose an effective serving after 40. Muscle tissue does not recognize brand names, marketing claims, or whether a protein came from milk, peas, rice, or soy. After protein is consumed, it is digested into amino acids. These amino acids enter the circulation and become available for many functions, including tissue maintenance and the construction of new muscle proteins. One amino acid is particularly important in this process, leucine. Leucine acts both as a building block and as a signal. When enough leucine becomes available after a meal, it helps activate a cellular signaling pathway known as mTORC1. Activation of this pathway signals muscle cells that amino acids and energy are available, allowing muscle protein synthesis to increase. The article estimates that many adults need approximately 2.5 to 3 grams of leucine in a meal to produce a strong muscle building signal. That threshold is not identical for everyone. Age, body size, activity, training status, total protein intake, and the composition of the meal can all influence the response. However, the basic principle remains useful. Consuming protein is not only about reaching a daily total. Each serving must also provide a sufficiently strong amino acid signal. This becomes increasingly relevant with age because older muscle can develop what researchers call anabolic resistance. Anabolic resistance does not mean that older adults cannot build muscle. It means that the same small dose of protein may stimulate a weaker muscle protein synthesis response than it would in a younger adult. In practical terms, older adults may need a larger protein serving and a larger leucine signal to achieve a comparable response. Whey protein naturally contains a high proportion of leucine. According to the article, whey contains approximately 11% leucine by protein weight, while pea and soy proteins contain closer to 8%. That difference may appear small, but it becomes meaningful when comparing equal serving sizes. For example, 25 grams of whey protein may provide approximately 2.75 grams of leucine. That would place the serving within the proposed leucine target. 25 grams of pea protein, however, may provide only about 2 grams of leucine. The plant protein is still providing amino acids. It is not useless and it is not nutritionally empty, but at that serving size, it may produce a weaker leucine signal. This helps explain why some short-term studies find a greater muscle protein synthesis response after whey protein. The studies are often comparing equal quantities of protein rather than equal quantities of leucine or essential amino acids. Whey may also have advantages in digestibility and absorption speed. It is rapidly digested, allowing amino acids to appear quickly in the bloodstream. This produces a relatively sharp increase in circulating leucine and other essential amino acids. Many plant proteins are digested somewhat more slowly and may have lower digestibility. Some also contain naturally occurring compounds that can modestly interfere with digestion or amino acid availability. Therefore, gram for gram, whey is generally more efficient at delivering a rapid and concentrated essential amino acid signal. But being more efficient per gram does not necessarily mean that plant protein cannot produce the same outcome. It may simply mean that plant protein requires a larger or better formulated serving. The article highlights a 2025 systematic review and meta-analysis that combined results from randomized controlled trials comparing plant and animal proteins. Across all ages, animal protein showed a small advantage for muscle mass. However, when the researchers examined older participants separately, the difference was no longer apparent. Among adults aged 60 and older, plant and animal proteins did not produce significantly different effects on muscle mass. The pooled results also found no significant difference between plant and animal protein for muscle strength or physical performance. The type of plant protein mattered. When soy protein was compared with milk protein, the analysis found no meaningful difference in muscle mass. The apparent animal protein advantage was more evident in studies involving other plant proteins, including rice, oat, chia, and potato proteins, as well as whole plant-based dietary patterns. This distinction is important because plant protein is not one uniform substance. Soy protein has a relatively complete essential amino acid profile and a substantial research base. Pea and rice proteins can also complement each other because one source can supply amino acids that are relatively limited in the other. A poorly formulated single-source plant product is not necessarily equivalent to a high-quality soy isolate or a balanced pea and rice blend. One of the most informative studies described in the article directly tested whether leucine explained the difference between whey and plant protein. The researchers compared 3 conditions: a plant-based protein blend, the same plant blend with additional leucine, and whey protein. Muscle protein synthesis was measured using stable isotope tracers and muscle biopsies. All 3 protein treatments increased muscle protein synthesis above baseline. However, the standard plant blend produced a smaller response than whey. When leucine was added to the plant blend so that its leucine content more closely matched whey, the difference disappeared. The leucine-fortified plant protein stimulated muscle protein synthesis to a similar extent as whey. A longer resistance training study produced a comparable result. Participants consumed either whey or soy protein, but the servings were adjusted so that both provided the same amount of leucine. After 12 weeks of resistance training, the groups experienced similar improvements in muscle growth and strength. These results suggest that protein source may sometimes function as a proxy for amino acid composition. Whey often performs well because it naturally provides a large amount of leucine and other essential amino acids in a relatively small serving. When plant protein is formulated or dosed to provide a comparable amino acid signal, the difference can become much smaller. A younger adult may receive a substantial muscle protein synthesis response from approximately 20 grams of a high-quality protein. After 40, and particularly later in adulthood, a larger serving may be more reliable. The article recommends roughly 30 to 40 grams of protein per meal, depending on the protein source and the individual. This is one reason the comparison between 1 scoop of whey and 1 scoop of plant protein can be misleading. If 1 scoop of whey provides 25 grams of protein and nearly 3 grams of leucine, while 1 scoop of plant powder provides 20 or 25 grams of protein and approximately 2 grams of leucine, the products are not providing equivalent physiological doses. A more appropriate comparison might be 25 to 30 grams of whey protein versus approximately 35 to 40 grams of a plant blend. The plant serving is larger, but it may deliver a similar amount of leucine and essential amino acids. This leads to a simple conclusion. Plant protein may not be inferior. It may simply be less concentrated. For someone who prefers plant protein, several adjustments can help close the gap. First, choose the serving based on the protein and leucine content rather than automatically following the scoop size printed on the container. A serving of approximately 35 to 40 grams of plant protein may be needed to provide an amino acid signal comparable to a smaller whey serving. Second, choose blended or higher quality protein sources. Pea protein is relatively rich in lysine but lower in methionine. Rice protein has a different amino acid profile and can help complement pea protein. This is why pea and rice combinations are common in well-designed plant protein products. Soy protein is another strong option. Among the plant proteins examined in the article, soy had some of the most consistent evidence for supporting muscle mass and strength. Third, examine the label for leucine or essential amino acid content. Not every product lists leucine, but some plant protein blends add leucine to improve the anabolic amino acid profile. Adding approximately 1 to 2 grams of leucine was the intervention that allowed the plant blend in the cited study to produce a response similar to whey. However, protein should not be reduced to leucine alone. The body still requires all essential amino acids to construct complete muscle proteins. Leucine may help activate the process, but the remaining amino acids provide the raw materials needed to continue it. Whey remains an excellent protein source. It provides a high concentration of leucine, is rapidly digested, and allows someone to obtain a strong amino acid signal from a relatively small serving. This can be especially useful for people who have low appetite, difficulty consuming large meals, or high protein requirements. It may also be more convenient immediately after training because a relatively small shake can provide a substantial dose of essential amino acids. The article also mentions a study in older adults in which whey, but not pea protein, reduced certain markers of muscle damage after long distance walking. That is an interesting finding, although one study is not sufficient to conclude that whey is always superior for recovery. Still, it suggests that differences between protein sources could potentially appear under specific exercise or recovery conditions, even when long-term muscle growth is similar. Plant protein may be preferable for individuals who experience bloating or gastrointestinal discomfort after dairy-based products. Some people have difficulty tolerating lactose, although whey isolate generally contains less lactose than whey concentrate. Others simply prefer plant protein because of dietary preferences, allergies, taste, or environmental considerations. Adherence also matters. A theoretically perfect supplement provides no benefit when someone dislikes it, cannot digest it, or consistently avoids taking it. The most effective protein source is one that provides adequate essential amino acids and can be consumed consistently as part of an overall diet. Protein powder is only one part of protecting muscle after 40. The article emphasizes several variables that may matter more than whether the powder comes from milk or plants. The first is total daily protein intake. The article proposes approximately 1.6 to 2.2 grams of protein per kilogram of body weight per day for supporting muscle retention and training adaptations. The exact requirement will differ between individuals, and the upper end may not be necessary for everyone. The second is protein distribution. Instead of consuming very little protein during the day, followed by one extremely large dinner, it may be beneficial to distribute substantial servings across several meals. The third is resistance training. Protein provides amino acids, but resistance exercise provides the mechanical stimulus that tells muscle tissue to adapt. Without progressive resistance training, simply changing protein powders is unlikely to produce dramatic changes in muscle mass. Sleep, recovery, total calorie intake, health status, and consistency also influence the outcome. These factors are less exciting than debating whey versus plant protein, but they often determine whether either supplement works. So, is whey protein better than plant protein after 40? Gram for gram, whey is generally more efficient. It contains more leucine, is rapidly digested, and can provide a strong muscle-building amino acid signal in a smaller serving. But efficiency is not the same as exclusivity. Plant protein can support muscle mass and strength, particularly when the serving is large enough. The product contains a balanced mixture of essential amino acids, and leucine intake is adequate. A practical approach would be approximately 25 to 30 grams of whey protein per serving, or roughly 35 to 40 grams of a high-quality plant blend, depending on the product's amino acid composition. Choose soy, a pea and rice blend, or another product that clearly provides a complete essential amino acid profile. Consider leucine-fortified products when appropriate. Most importantly, pay attention to total daily protein, distribute it across meals, and combine it with challenging resistance training. The protein source matters, but probably less than the dose, the amino acid profile, and what you do with your muscles after you consume it. The real debate is not simply plant versus whey, it is whether your protein serving provides enough of the right amino acids, whether your total diet supports recovery, and whether your training gives your body a reason to maintain and build muscle. Choose the protein you tolerate, enjoy, and can use consistently. Then make sure the serving is large enough to do the job. Thank you for listening.